All right, do we have any questions on last night's homework? What? We only had class 4 times Okay, what was last night's homework? Where are we?
Graphics.
Oh yeah, graphing. What's the last problem? 87. Did the book have the answers in the back too? That looks weird. That looks strange. This graph is not right. Where's okay, this graph is not right either. Wait, is this? Oh, maybe it is right because I don't know. Let's just do it on the board. And then what's it? I don't know. See, look, 87, I'm seeing all kinds of different things. Okay, we need to do number 87. Okay, who sits there?
Ogilvy.
Oh, Ogilvy. 87. Okay, what's the equation for 87? So yeah, we'll be having a quiz coming up soon. Okay, the first thing you gotta do is you gotta make sure everything is all factored. Is this all completely factored? No. So this can be factored as x plus 1, x minus 1. But then that's an x plus 1, so isn't that like squared there? So you have to write it in factored form, and then once it's all in factored form, now we are ready to graph. So the x-intercepts are 0, -1, and 1. 0, -1, and 1. And then if you were to multiply everything, the first term would be -x to the 5th, correct? So it's odd degree, leading coefficient negative, so the end behavior could be like this. So it's going to be like that, and like that. So I'm coming down over here. How come? Oh, I forgot to plot the y-intercept. Oh, the y-intercept is 0. Okay, so here we go. So I bounce off this one. How come I bounce off that one? And then I bounce off this one. And then this one you go through. That's what the graph. Remember, even power, the graph can bounce off. Odd power, the graph goes through. Because some of you just had like nothing there. It's like flat. Flat, or it's just you didn't know what was happening. Okay, and then what was the problem before 87? I saw some different answers on that one. Number 81. Should we do 81? I think so. Oh, so is that what's throwing you off? The factoring. Y equal x minus 1 squared times. No, this one is not even. So this is 81. Are the answers to the graphs in the back? Yeah. So 1, 3, -1, and the y-intercept is going to be, if you plug in 0, is going to be 1 times -3 times 1, which is -3. 1, 2, 3. And then if you were to multiply this out, this would be x to the 4. So leading coefficient positive, the end behavior is like this then. So I'm coming down to here. Do I go through or bounce off? -1 came from here, odd power, you go through. And then now I'm coming up to 1. This one you bounce off because 1 came from here, see, even power. And then now I go through because 3 came from there, odd power. And then, okay, any other questions? We got this down?
So you know when there's a negative in front of the first x,
Mm-hmm.
when do you know when it's coming from the bottom or from the top? Like,
Oh, because you gotta look, you have to, so if you were to multiply out everything, the first term would be this, right? The first term tells you the end behavior. So if it's odd degree, if that's an odd number, then it would be either like this or like that, right? But since the leading coefficient is negative, then it's gonna be like this.
oh, okay.
So that first term tells you the end behavior, if it's A, B, C, or D. Just like this one, if I multiplied it all out, this is the first term, right? So even degree means either bolt up or bolt down, but since the leading coefficient is positive, it'll be bolt up. But if the leading coefficient was negative, then it would be bolt down, like that, yeah. All right. So we're going to be drawing some more graphs. Actually, tonight's homework, you're not going to be drawing graphs. However, no, you are going to be drawing graphs. Okay? So why don't I just do some examples that are just like the homework problems, and then hey, we can finish early today. So, what kind of functions were we graphing on last night's homework, the last 2 nights? What do we call that? Polynomial functions. Polynomial functions are where you have whole number powers. Okay, but now we're going to be studying rational functions. What the heck is that? Did you guys do this in 2A? Rational functions? It doesn't matter, I'm going to teach you if you don't know anything anyway. A rational function is a function of the form P of x over Q of x, where P and Q are polynomials. So when you have a polynomial over another polynomial, for example, something like this, y equal 2x squared plus 3x plus 4 over 3x squared plus 4x plus 5. This would be a rational function. See how you have a polynomial over a polynomial? Now the thing with these functions are, now it's going to be kind of fun because now they're going to be asymptotes in the graph. Did you guys talk about asymptotes in 2A? Here, I'm just gonna draw you a graph. You don't have to know how to graph this yet. We're gonna learn that tomorrow. But I'm just gonna show you an example of a rational function. Like, let's do an easy one. 2x minus 1 over x minus 2. Yeah, okay. So if I were to draw this graph, okay, like I said, you don't really have to know it now. I'm just gonna show you. You plot the x-intercept, which is a half. How did I get that? That you should know. How do you find the x-intercept of any graph? You set y equal to 0. And if a fraction is equal to 0, does that mean the top is 0 or the bottom is 0? The top, right? Because if the bottom is 0, it's undefined, right? So that means the top is 0. So to find the x-intercept, basically you just look at where is the top 0? What makes the top 0? 1/2, right? That's the x-intercept. Now how do you find the y-intercept? You plug in 0 for x. If I plug in 0 for x here and here, you get -1 over -2, which is half. There you go, that's the y-intercept. See, so that's what we did in polynomial functions. See, but in rational functions, we have these things called asymptotes. So in this problem, see the denominator? What makes the denominator 0? 2. So at 2, the function is undefined, right? Because something over 0 is undefined. So what happens is there's a vertical asymptote, like that. And then, if there's a vertical asymptote, could there be a horizontal asymptote? Yes, in this case, it's going to be y equal 2. And I will teach you that not today, but tomorrow. So, you have the graph. You got the x-intercept, y-intercept, and these asymptotes. Now, how does the graph look? Well, when you have asymptotes, it's actually easier to graph. The graph looks like this. And then on this side of the vertical asymptote, you have the graph would look like this. So that's what a typical rational function looks like. See? So when you have a vertical asymptote, see how the graph just, it gets closer and closer but it doesn't touch it? That's what an asymptote is. Same thing over here. And then when you have a horizontal asymptote, as the graph goes out to the left and the right, see how the graph gets closer and closer to the horizontal asymptote like that? So that's one of the features of rational functions. There's vertical and horizontal asymptotes. Now, are there other kinds of asymptotes? Yes, there we have slant asymptotes. But see, when the graph goes out here, the graph will get closer and closer to it like that. And then you could have these other things like parabolic asymptotes. See, but we're Algebra 2B, we don't even learn those. All you have to know are vertical and horizontal asymptotes. See, and if you look at the examples in the book, look on page 353. Did you guys even bring your book? -1 for each page missing. How many pages you got again? 1,000 something. Imagine you get 1,000. We don't even have 1,000 points in a quarter. All right, so that's what a rational function looks like. So we're going to spend 2 days on this. Now today's one is really easy. It's like it's so ridiculous. You can do this homework in less than 15 minutes. Okay, so look at the homework. What do we got here? 15, 17. So why don't I do number 16 then? Since you have to do 15 and 17. So here's number 16. Q of x equals -x over 1 minus x all over 3x squared plus 5x minus 2. Now the directions are, find the domain. That's so like, this is ridiculous. How do you find the domain? Well, if you have a fraction, you just have to make sure the denominator cannot be 0. So you just got to figure out when the denominator is 0. So if I have a quadratic like this, how do I figure out what makes it 0? You either factor it or use the quadratic formula, right? In this case, hopefully it factors 3x and x, 2 and 1, plus and minus. Yes, it factors. So what values of x will make the denominator 0? 1/3 or -2, right? So what is the domain? The domain is x such that x cannot equal 1/3 or -2. Like that. Right? X can be any number except these two numbers because it makes the denominator 0. Or if you want to write it like this, -infinity to -2, and then from -2 to 1/3, and then from 1/3 to infinity. Which way you like better? Basically, it's any number except -2 and 1/3. I think I like the top one better. And like I told you before, since this is Algebra 2B, if you just wrote that, that would be correct. But since a domain is a set, then you should write set notation. That's correct mathematics. See how easy? So all those problems, you just got to make sure the denominator is not 0. And then you have 23, 27, 29.
So you don't have to do anything at the top.
No, because just remember, when you have a fraction, what would be the only thing that makes the fraction undefined? The denominator got to be 0. So the top doesn't even matter. You don't even look at the top, you just look at the denominator. Okay, and then they give you a graph. Why don't I do number, I'm going to do one of the even ones. Which one looks interesting? 24? Oh, it looks kind of babyish. Yeah, what the heck, let's just do 24 then. So they give you a graph that looks like this. Woo! And then they go 1, 2, 3, 1, 2, 3. Here is the point 0, 2. And then they have this thing over here. And then the graph looks like this. Yeah. Okay? And then you just got to answer the questions. A, what is the domain and range of each function? Come on! So domain. Remember now, domain is a listing of all the x values on a graph. So if you were to list all the x coordinates on this graph, you would have everything except what? Yeah, because -1, there's a vertical asymptote there, right? So So how do you write all real numbers except -1? Probably this is the easiest way. X such that x cannot equal -1. Now range. Range is a listing of all the y coordinates on the graph. So if you listed every single y coordinate on this graph, what do you have? Yeah, it's got to be bigger than 0, because here's 0, it's all above it. And does it include 0 or doesn't include 0? It doesn't include 0 because, look, this graph is getting closer to the x-axis, but it doesn't touch it, yeah? So, y such that y is greater than 0. That would be your range. Or you can just write, like I said, 0 to infinity. That's perfectly fine too. Okay, B, intercepts, if any. Well, x-intercept. Where does this graph touch the x-axis? It doesn't touch the x-axis, so x-intercept, none. Y-intercept. Where does this graph touch the y-axis? At the point 0, 2. So you could write either 0, 2, or you could write just 2. I would prefer just 2 like this. But it doesn't matter. Horizontal asymptote, C. Now, does this graph have a horizontal asymptote? Like, is there a horizontal line where the graph gets closer and closer to it? Yeah, because look, as the graph is going out to the right and the left, look, it's getting closer and closer to the x-axis, right? So what's the equation of the x-axis? No, y equals 0. Remember, vertical line is x equals something, horizontal line is y equals something. D. Vertical asymptote. Well, God, they kind of drew it in right there, right? Here's the vertical asymptote. See how the graph gets closer to it? So what's the equation of this vertical line right here? This dotted line right here. X equals -1. And then finally, E oblique asymptote. Okay, we're not going to... Oblique asymptote would be an asymptote that's slanted, but we're not going to even do that. So I'm pretty... Like 26 has a, and 28 they have a slanted asymptote, but we're not going to... I don't think I assigned that, because we're not going to study... When you go to pre-calculus, then you'll study slant asymptotes. And then the last part of your homework tonight is 31, 33, 37. Oh, so you have to actually graph these by using transformations. Oh, I get it now. So what they want you to do, well, first of all, you got to know these base graphs. I don't know if you guys learned. Did you guys learn this graph in 2A? Yes or no? Oh, you guys did. Oh, good. What about this one then? No. How come you guys learned that one but not that one? Okay. Anyway, what do you guys remember about this one? Okay, here. Here's the point 1, 1. Here's the point -1, -1. Does that look familiar? And then, so if you were to plot points, you would get something that looked like this. Yeah? But these are the key points: 1, 1. Here, I'll write it. And then -1, -1. You can see, right? If you plug in 1, you get 1. You plug in -1, you get -1, right? So you can see what's the vertical asymptote here. X equals 0. What's the horizontal asymptote? Y equals 0. Now, what about this graph? Well, it kind of is the same, but different. Because if you plug in a 1, you still get 1. But what happens when you plug in -1? You get +1. So these are the two key points for this graph. That would be 1, 1 and -1, 1. Ah, I shouldn't have drawn it. Ah, well, too late already. Anyway, this is how the graph looks. And then so for tonight's homework, these are your two base graphs, okay? And if you forget what they look like, just like plot a point for 1 and plot a point for -1. Because in both graphs, look, the vertical asymptote is the y-axis and the horizontal asymptote is the x-axis. Now, what you have to do is you have to graph these by using transformations. So, let me do one. How about number 30 then? 30, we got y equals 3 plus, I forgot what it was, 1 over x squared. Okay, now do we know what the graph of that looks like? Yeah, it's this one right here. So what does this 3 do to the graph? shift it up 3. So all you're gonna do is take this graph and shift it up 3. So how do you do that? Well, these 2 key points, if you're at the point 1, 1 and you shift it up 3, 1, 2, 3, where you gonna be? 1, 4, right? And if you're at the point negative 1, 1, and if you shift it up 3, where you gonna be? Negative 1, 4, correct? But everything gets shifted up. So you see this horizontal asymptote, it's on the x-axis. If you shift it up 3, then isn't it gonna be over here now? Y equal 3? So if you shift up everything 3, what does the graph look like? It's gonna look like this. I like that song. It's a good one. There you go. That's all you gotta do. See, the other Algebra 2 teachers, you know what? I think they want you to plot more points. Like they want, you know, instead of just this point here, they also want you to plot like 2, 1/2, and 1/2, 2, I think. But I don't want you to do it, I just want you to do that. Okay, and let's do one with the other one. How about, let's do 38. 38, y equals 2 minus 1 over x plus 1. Oh, this one got 3 things you gotta do to the graph. Okay, so what's the base graph? Is it A or B? Yeah, it's A because it doesn't have the square on it, right? So here's the base graph. So first of all, what does this do to the graph? That minus sign. You guys remember? You multiply by negative 1, that's going to reflect it over the... Okay, let's look at like something we know. If you have y equal x squared, how did you graph y equal negative x squared? What does y equal x squared look like? Doesn't it look like that? What about y equal negative x squared? Doesn't it look like that? What happened to it? It got reflected over the x-axis. So when you multiply a function by negative 1, it reflects it over the x-axis. So the base graph is this. What would happen if you reflect it over the x-axis? This one goes up and this one goes down, right? So then, instead of there, the key point will be here now. And instead of there, the key point will be there. So now, this key point is 1, negative 1, and this one is negative 1, 1. So this is what we have now. I'll just do dotted line because that's not the finished graph yet. And then, okay? Now, what does this do to the graph right here? This will shift it 1 to the left, and what does that do? That one shifts it to
down.
what?
Oh wait, that's not.
That's a 2. Isn't that the same thing as just like putting a plus 2 at the end? Is that going to throw you off just by putting it in the front?
No, I thought the equal sign was a negative sign. So I thought it was negative.
Okay, so this graph needs to be shifted 1 to the left and 2 up. So every single point gets shifted 1 left and 2 up. So this point, if I go 1 left and 2 up, where am I going to be? Yeah, let me draw it better. I guess I should look that. So look, if you're at negative 1, 1, if you go 1 left and 2 up, where are you going to be? Negative 1, 3. And then this point too, if I go 1 left and 2 up, I'm going to be over here. Where's that? That one's kind of easy. 0, 1. But then the asymptotes also get shifted too. So what would happen? So here, this is kind of like, maybe you should think about that. That's the key point there too. What if I were to shift this point 1 left and 2 up? You would be right there. So that's where the vertical and the horizontal asymptote meet there. Everything gets shifted. So now the graph looks like, here's your final product. There you go. Kind of easy, huh? So yeah, you really don't have to like draw like difficult graphs yet. We'll do that tomorrow, the more difficult ones, the fun one. Because all you have to do on tonight's homework is take these 2 graphs and then like shift it left, right, up or down, left it over the X, left it over the Y. Pretty easy. Any questions? All right, then I'll give you the rest of the time then, and then you can probably finish this. So when does class end?
10.
We're on A, huh? 9, 10. Got 30 minutes left. It's an outrage. Maybe we're going too slow. Maybe you gotta combine lessons together. No, we're not gonna do that. Yeah. Yeah. And then you can make up last week's homework. So my guess is we're gonna have a quiz, we can't have it tomorrow. Monday probably gonna have a quiz. Monday. It'll cover 5.1 and 5.2. In fact, let's put it in writing already. Alg2B quiz Monday. Because then I don't even see one Tuesday.